Okay, this video is on gas stoichiometry. It's exactly what it sounds like. Okay, it's stoichiometry problems involving gases. Now, the important thing to know is that when we were looking at, say, stoichiometry, we always started with a reaction. Okay, so I'm going to go ahead and just say A plus B forms, A2B3. That's not a 3. Let's try that. That's better. So, and of course, if I was to, have this equation, the very first thing I need to do is I need to balance it. So I'm going to go 2 A's and 3 B's. Very nice, easy balancing of an equation. Okay, so now I have my coefficients. Now, even though I don't write it here, right, there is a 1 right there. So what do these coefficients mean? Okay, we've talked about this in the past, right? We know they could possibly mean, right, molecules or atoms, right? I have one atom of A and one atom of B is going to make two atoms of A, 3 atoms of B is going to make one molecule of A2B3, right? We know it could be that. We also know it could be moles, right? I have 2 moles of A will react with 3 moles of B to form 1 mole of A2B3. Okay? Well, when it comes to gases, right, if I have all of my species, in this case, representing gases, or being gases, okay, these numbers could take on yet another meaning, right? They can mean liters, right? If I have 2 liters of A and 3 liters of B, I can make 1 liter of A2B3. Now, there is an important condition here. This must be at standard temperature and pressure, okay? So, under standard temperature and pressure, we know that I can use these coefficients as liters and not just moles or molecules or atoms. Okay, so it's just an additional way to do it. There is another possible meaning for these coefficients, and that could be atmospheres, but I am not really going to focus on this. I'm going to mainly focus on liters. Okay, so let's go ahead and get started on an example problem. Okay, so hydrogen gas and oxygen gas react to form, okay, form water, which in this case would be a gas, water vapor. Okay, so I have my balanced equation. Well, first thing I have to do is write out my equation, right? And I should be able to knock out balancing real quick, right? So 2 moles of hydrogen gas react with 1 mole of oxygen gas to form 2 moles of water. Okay, in this case, all gases, right? So, if I was to do a normal stoichiometry problem, I can do, number of grams of H2, and you should be able to give me the number of grams of H2O. Or if I have that number of grams of H2, you should be able to tell me how many grams of O2 reacted with it. Or if I have, grams of H2O, right, you should be able to tell me how many, grams of O2 I needed to make it. Okay, there's a wide variety of different things that you can do with stoichiometry. Okay, once you realize that you have the balanced chemical equation and you know what the molar ratio is, and of course there's that one key factor, right? If I'm going from if I'm going from, like, say, moles of one thing to moles of another, like moles of hydrogen gas to moles of water, all I need is the molar ratio, right? If I have the molar ratio, I'm good to go. Okay? Well, if I'm going from, grams to moles, or moles to grams, well, in addition to the molar ratio, I'm also needing one additional piece of information, and that is the molar mass of whatever substances I'm looking at. And of course, I can get that from the periodic table. Now, when it comes to gas stoichiometry, I'm going to be dealing with liters, right? So I can go from liters to moles, or moles to liters, or even grams to liters, and liters to grams, and back and forth. But when liters are involved, right, then I need yet another piece of information. Now, if I'm just dealing with liters, I don't even need to use molar mass. So it's not really even a plus. It's more of an or. It's not really a great line, right? So if I'm dealing with grams and only grams, I use molar mass. If I'm dealing with liters and only liters, I need this other little important piece of information, which you should have solved for when you did ideal gas laws, right? PV equals nRT, right? The volume of the 1 mole of any gas, remember, and it's at standard temperature and pressure, right? 1 mole of any gas, does not matter what that substance is 22.4 liters, right? And that is what we call the molar volume, okay? Molar volume, okay? So, in knowing this, if I go from, say, grams of one thing to grams of another, I'll use molar mass. If I go from liters of one thing to liters of another, I'll use the molar volume. But if I go from, say, grams to liters, say I go here, right? Well, if grams are involved, I need to use molar mass. If liters are involved, I need to use molar volume, okay? So keep that in mind. If liters are involved somewhere in the problem, I need to use this value. Now, the great thing is the molar volume is absolute for every single type of gas, doesn't matter what the gas is. Okay, it could be water, H2O with, fairly large compared to, say, hydrogen gas, which is just 2 atoms of hydrogen, or a molecule of decane, which is many, 10 carbons and 22 hydrogens. All of that, it's still, if I have that gas at standard temperature and pressure, it's only going to occupy 22.4 liters of volume. Okay, so just a thing you need to realize, right? If I have grams involved, I'll use the molar mass. If I have liters involved, I'll use the molar volume. If I have both involved, I'll need to use both. Okay, so for this problem, right, I'm going to go ahead and let's pick a number. I have 27.4 grams, not grams, liters of hydrogen gas. And I want to know how many liters of water vapor I can make, right, based on that. So, pretty simple, right? Start with what I'm given, which is 27 point, all right, don't want that, need a little red in there. 27.4 liters of H2, right, over 1. And then I need to get to moles, because I need to use molar ratio regardless, right? When it comes to when to use molar ratio, if you're dealing with more than one substance, you're using molar ratio. In this case, I'm still going to use molar ratio, right? Because if I have 27, so I'm going to end up with 22.4 liters of H2, right, is 1 mole of H2, okay? And then here's where I use so this was my molar volume. Now this will be my molar ratio, okay? In this case, I have 2 moles of H2 for every 2 moles of water. And then I do the same thing. I go, well, for every 1 mole of H2O, and since it's a gas at standard temperature and pressure, it's 22.4 liters of H2O. Okay? Now, obviously, we can play with some numbers right here because there's not only units canceling out, but some numbers are canceling out. Okay? So I'm going to go ahead and cancel out my moles of water, my moles of hydrogen gas, my liters of hydrogen gas, but I can also cancel out my 22.4 and 22.4, okay, because it shows up on both sides. Okay? So now you're thinking, well, keep in mind, I'm just canceling out the number. I'm not canceling out that unit. Okay? I didn't cancel the unit, I just canceled out the number. So all I do in this case is do the math, which if you look at it, it's multiplying by 2 and then dividing by 2. So if I had 27.4 liters of hydrogen gas, I am going to produce, right, 27.4 liters of water, right? Okay, so that would be my answer. Now, if I was to do oxygen gas instead of, hydrogen gas, then this number right here, okay, that number right there would have been a 1. Right? It would have been 1 mole of O2. So instead of it being exactly the same, it would be twice as much. Okay? But it's pretty straightforward. That's how you're doing these types of problems. Okay? So you're just following the same rules you did with all stoichiometry. Okay? But now we have another component in there. We have that molar volume. So let's do a problem, and I'm going to use the same narrative, okay? But now I'm going to pay attention to, let's say I had 47, that's not a 46.8 liters of oxygen gas, and I want to know how many grams of water was made, okay? So I'll need a lot of different information here, right? Liters are involved, I need to use molar volume. Grams are involved, I need to use the molar mass, okay? So let's start it off. 46.8 liters of O2 over 1, okay? For every 1 mole of O2, okay, we have 22.4 liters of O2. Now, even though it doesn't say so in the problem, this is at STP, okay? You're never going to see anything in this class that if you have a gas stoichiometry, it's not going to be it'll be at stand temperature and pressure, okay? So from there, I go oops, I messed up on that, didn't I? Ha, 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 ha. Saw that. Okay, so 22.4 liters of O2 for every 1 mole of O2, right? And now I need to go moles of O2 to water moles. So 1 mole of O2 for every 2 moles of water, okay? And then I need to go from moles of water to grams of water. So 1 mole of H2O is equal to 18.02 grams of H2O, and I get up that from the periodic table. Okay, so if you go ahead and do the calculation, okay, that value is 1,686.672, which of course is atrocious, right? We need 3 sig figs, so 1690. Okay, divided by 22.4, my final answer with 3 sig figs is 75.4 grams of water. So what does that mean? That means I can produce 75.4 grams of water if I start off with 46.8 liters of oxygen gas. Okay? Just to kind of show you the difference, right, is, 75.4 grams of water vapor, okay? And then it took 46.8 liters worth of oxygen gas to give, that's 23 2-liter bottles worth of oxygen gas to make 75 grams of water vapor, okay? But as you can see, I used a variety of different things here, right? Here I used molar volume. Why? Because I need to get to moles. Here I used molar ratio. Why? Because I need to go from one substance to the other. Here I used molar mass because I need to go from grams or moles to grams. Okay? It's all the same stuff, folks. It's just you have to realize what information what conversion factors are important for the particular question. Okay? Obviously, if I wanted just moles right here, then I wouldn't even use the last step. I'd be done. Or if I wanted liters here, I would use molar volume again, right? Just like I did on the previous problem. So that's how you do gas stoichiometry problems. All right. Pay attention to molar volume. Okay, 22.4 liters is any gas, right? A mole of any gas is 22.4 liters. Okay, if you remember that, you remember how to calculate molar mass, you know how to balance equations, you should be good. Okay, or okay, and sorry, I shouldn't say or, and arguably the most important thing is being able to take words, right? Take these words right here and put them into an equation, which some people are still having issues with. Okay, so you should know which elements are which elements are diatomic molecules. You should know what how to use the nomenclature like nitrogen trihydride or nitrogen trifluoride or phosphorus tribromide or whatever. Right? You should be able to use that information to get the proper formulas. If you don't get the proper formulas, you can't balance the equation. If you can't balance the equation, this step you can't do. Because if you can't balance the equation, you're stuck. All right? So, if you guys have any questions, please ask.